This is Sayoshi Nakamario, and today we're going over the CashStarter contract, which is what runs behind the FundMe.cash website, crowdfunding website. So this is the GitHub for CashStarter, Sayoshi Nakamario, CashStarter. There's a little README going over the contracts. So FundMe, or rather CashStarter, is a series of 6 contracts. We have the manager, CashStarter itself, and then 4 function contracts, which we'll go over in a little bit, that interact with the CashStarter contract itself. So before we go over this, we'll go do a quick overview. So this is a quick high-level view of the contract. So first we have the CashStarter manager contract in this square, and then we have the CashStarter contract itself in this square. So when a user interacts with CashStarter, what they're doing is they're calling this initialize function on the manager. And it'll run through its logic and use this manager NFT that's here. And this is a minting NFT, and this is the only one that exists inside of this contract. And it has this category ID. So this minting NFT of this ID will, after you initialize, it'll create one of these campaign NFTs. So when somebody actually creates a campaign, it's creating one of these guys right here. And this campaign NFT is going to have the same category ID as the manager. So it's basically creating little child NFTs of itself. And again, this category NFT, the category of this NFT is only on the CashStarter manager contract. So that's the only way they can create is by using the initialize function, which has to go to this contract. So on this contract, the CashStarter contract now specifically, there's 2 functions. There's pledge and external function. So to start with, pledge only allows you, anybody to put Bitcoin Cash onto one of these campaigns. And one of these campaigns, it does check, we'll go over the code, but it does check that the category ID is what the CashStarter one is, which verifies that it has to be an actual campaign NFT that you're interacting with. External function, so most of the logic has to do with the pledging, but I still needed a way for the CashStarter contract itself to have more functionality than just pledging only. And a workaround for that was to create this little external function, which again, we'll look at the code, but it's very simple. All it does is check to see that we're interacting with another category of this type. So again, this category should only exist on the CashStarter manager. It should only be a campaign NFT, or the way this contract system was set up, it's one of these functions down here. So these are also the same category. So in the CashStarter contract, this external function allows these 4 extra functions to be called. And these ones will do different things. Obviously, cancel, claim, refund, and stop the campaign. So this is just kind of a high-level view of what the CashStarter contracts are, which FundMe.cash uses. We'll go over all the specifics. It's pretty simple. There's only 2 major contracts, and then there's a couple little function NFTs on the side. So back to the GitHub. Just going through this real quick. So this gives a shorter version of what I just went over. So the CashStarter manager lets you create a new campaign, and it sends it to the CashStarter contract. The CashStarter contract itself holds all of the campaigns, and then pledgers, people can pledge to them. And as a pledger, you'll also get a receipt NFT back, and that's the NFT that allows you to refund your pledge. And then these are the 4 function NFTs, which allow you to refund your pledge, stop a campaign if it's exceeded whatever block is supposed to end by. And anybody can call this. And it also doesn't take a fee from the person, so you don't even need BCH or know what crypto is to cause this to happen. Canceling, this is if the creator of a campaign wants to actually cancel their campaign before it's ended, before it gets stopped. And that's just kind of on the campaign creator themselves choosing to stop things. And then claiming is if the campaign creator wants to claim their funds because it succeeded and at least got 100% of what they're asking for. And then a basic design of this current FundMe contract, which I'll be changing on the newer versions, is that it has incentivized front ends. So anybody can, in theory, run a front end for the site, either in an app or on a different website. And they'll earn some of the claiming fee that people are charged. And then the campaign data. So currently on FundMe or on the CashStarter contract, only FundMe is the app that is currently running any of the data or any of the campaigns. It started to get introduced into some wallet apps, but they're still pointing at the FundMe server. But they also don't need to. They could actually run totally separately themselves, or they could run new versions of the contracts. So. And then this just kind of shows some of the campaign limits for FundMe, or rather the CashStarter contracts. So the maximum number of campaigns, $500 million. You can raise 1.4 million BCH. You can pledge 1.4 million BCH. And the time that you can set a campaign to is technically year 11,521. So to start with, we'll do it from like the very beginning. So if you're somebody that wants to create a campaign, first you're going to be interacting with the CashStarter manager. So kind of similar setup as my other contracts you've seen, like the Badgers contract. We have the inputs and the outputs. So for the inputs, first one is the manager NFT for the CashStarter manager. So this is the main category I was talking about earlier, is this in this NFT. And it has to be the first inputs for creating a campaign. So this active input index equals 0 is basically saying that this NFT from the CashStarter manager contract has to be in number 0. And then the only other input is the user BCH. So just for the fee for creating the campaign has to be coming from the user's wallet. That's it. For the outputs, it'll create you recreate the manager NFT, which again goes back to the CashStarter manager contract. It creates a campaign NFT. So this is the actual campaign that you want to run, and it goes to the CashStarter contract. So different from the manager contract. The manager is what we're interacting with and calling initialize, and it will create a campaign to the CashStarter contract. Output 2 is a service fee to the service provider, and then, which we'll go over, and then output 3 is optional change back to the user. So the parameters that you need when you're doing this. So if you're calling initialize, you need to provide a pub key hash, and this is the campaign creator's pub key hash. So basically, input 1 is coming from the user. It needs to be that pub key hash for that user because we check it later. And then we provide an integer of fund target. So for example, if you want to create a campaign that has 10 BCH is how much we want to raise, that's what this number is 10. 10 BCH in Satoshis. And then we need to provide an end block. So this is the block number that we want the campaign to go until. And then once this block is hit, anybody can call that stop function, which will prevent new pledges from going on the campaign. And then we provide another pub key hash, and this is for the service provider. So this is, FundMe.cash in the current case, or this could be a wallet or a different website's pub key hash for providing the service of all the buttons to interact with the contract. And then there's also a service fee. So how much fee this pub key hash will get. So just going through the contract real quick, we have the input lengths we're setting to 2. So again, up here, we're specifying there has to be 2 exactly inputs. For the outputs, there has to be less than or equal to 4. So 1, 2, 3, 4. So again, optional change, since you can technically not have any change if you provide the exact amount of BCH. Here we're looking at input 1, and we're looking at the locking bytecode. So again, input 1 is the user's UTXO. So this is from the user's wallet. So we're looking at the user's wallet bytecode. And we are taking the pub key hash that we gave as parameter. So right there. And we're creating new locking bytecode with that pub key hash. So the pub key hash has to match what the input 1's locking bytecode is. So basically, the user providing the BCH for this forces it to be their actual pub key hash. So if this is a malicious website site trying to steal funds in some way, this will prevent them from providing a false pub key hash. This has to be the actual pub key hash for the user's address, and there's no way around that. And then we also check that input 1, which again is the user UTXO, has a token category of nothing. So 0x means it's hex, and there's nothing after it, so it's just blank. So this is forcing that the input being given by the user for input 1 is only BCH. There's no tokens on it, no NFTs, and this is just to prevent burning. So to prevent a wallet from accidentally giving a NFT or token, because you can technically have a BCH UTXO that also has a token or NFT on it, and this is just preventing those UTXOs from being allowed on the contract, just to prevent burning. And then we're just checking that the end block that was given as a parameter, so right here, when you want the campaign to end, is below this giant number, and that just has to do with the max value for CashScript for checking blocks. So if we just jump over to CashScript real quick, so if we look at transaction time, we can see that when comparing values below 500 million is treated as a block number. So this is what we're trying to use as block numbers. But values higher than that are treated as a timestamp. So we don't want to do timestamp. We want to do block number only. So we're restricting the value to this. And this end block, I don't know what it is off the top of my head, but that block number is like hugely gigantic. So that's super far into the future. So for us, that's nothing we need to worry about, that it's limited to that number. So for we then check service fee. So the service fee is the fee that the service provider is charging to interact with this contract. And we specify that it is 1,000,000 Satoshis or less. So that's 0.01 BCH. So at today's prices, that's like something like $5 roughly, $4 to $6 US or something like that. So this is just basically like a listing fee. So whoever you use to create the campaign has and this is how FundMe.cash works, is it'll charge 0.01 BCH just to create the campaign. So this can technically be excluded if a different service wanted to not provide that or charge that. It is kind of a way to prevent spam a little bit on the contract. And then fund target is just the how much BCH the campaign is asking for. So this is restricted to, I believe, 1.4 million BCH, and that has to do with it being the max 6 byte value, and then accounting for minimal encoding for the last byte. So basically just 1.4 million BCH is the max you can ask for, which is quite a bit. And then next we start checking the category of input 0. And so this is, again, input 0 is the manager NFT. So this is on the manager contract. We're checking input 0's category is equal to this, and it has to have the minting capability. So this category right here is the CashStarter category. And so this is kind of like the genesis for the campaign system is on this manager contract. So it's checking for this category. So this might be a little hard to see, but this category that we're looking at for the CashStarter manager, it's the same category as the one I have down here, but they're in different orders. So this one down here in the diagram is how a block explorer will show it. So if we just look at the end of it, for example, C964, so that's going to be in big endian encoding. But on the contract itself, it's going to be in little endian, and that kind of reverses everything. So C964, so instead of looking at the end, you look at the beginning, and if you check C964. And just to give a bit more of a clear view, so this is for the FundMe app. You can see I've put master category ID, and then also master category ID LE for little endian. So this is what it looks like in big endian on a block explorer or something like that. So again, 4837 at the beginning, C964 at the end. But on in the VM on Bitcoin Cash itself, and when you're doing all the contracts, because they're obviously using the Bitcoin VM, it's all in little endian, so it's reversed. So C964, but on this side it's 64C9. So exact same representation, just encoded a different way. This is something that tripped me up for a while till I figured it out. This is definitely something you have to be aware of. So back to the contract. So we are verifying that we're using the actual minting NFT for the CashStarter manager. So that's good. So next we're creating a campaign ID that is 5 bytes long. And we're getting it from the last 5 bytes of the manager's commitment. So we're splitting at byte 35. So again, we're looking at the manager NFT because that's input 0 that we're looking at. We're looking at its NFT commitment, and we're splitting at byte 35 and taking the right side of it. So that's 5 bytes, and we're saying it's a campaign ID. We're then checking that the campaign ID is equal to this value. So this is just all Fs, the highest value those 5 bytes can have. And this is just an arbitrary value I picked for identifying the master NFT. So this is the main minting master. And that's because the last 5 bytes of the commitments for the master, I was using as the value for the campaigns. So when CashStarter is first created, it starts at there's 0 campaigns. And then once one gets created, it becomes campaign 1 and then campaign 2, and it just keeps counting up. But it can never get to this because this is supposed to be the master minting NFT. And that's the value for it. So it'll actually prevent a campaign reaching this value. But this is a gigantic number. So again, that's like 500 million contracts or campaigns or whatever. So it's checking to make sure that we're actually using the campaign, or not the campaign. We're using the master minting NFT. We then look in input 0 again, and we look at its commitment, but we're splitting at the first 5 bytes this time. But we're also not picking a side, so there's no square brackets. So that means we're actually splitting the full 40 bytes, or whatever the length of the commitment is. In this case, it is the full 40, and we're going 5 in, and we're splitting it, and we're going to create 2 variables. So we're getting the campaign counter, and we're just saying the rest of the commitment, so the rest of the 35 bytes. We then create a new campaign ID because this is us initializing. We're creating a new campaign. And that campaign ID is going to be the campaign counter. So the 5 byte value that we just got. So this is the current number of campaigns that are currently existing. And we're just going to add 1. So if there was 5 campaigns on CashStarter currently, well, now we're going to add 1 more. So it's going to be campaign number 6. And that's what our new campaign ID is. And then we just check that the new campaign ID that we're creating is less than the max value of campaigns that we can create for CashStarter. And then at this stage, we're basically just creating or forcing our outputs to be created. So we're saying that output 0, all of these are output 0 related. We're saying that its commitments has to be, so again, output 0 is the manager. So we're recreating the manager minting NFT. So we're saying that its commitment is the new campaign ID in the first bytes, first 5 bytes. So this is the how many campaigns currently exist. So that's the first 5 bytes. And then we're just tacking on the rest of the commitments. So this was back from this split that we did. We didn't change the last 35 bytes. All we did was split it at 5. We had 35 left over. We just kind of hung on to that variable for a bit, and then we're just tacking it back on. So the only thing that's changing in the commitment is the fact that we're increased the campaign IDs by 1. We then say that output 0 is locking bytecode. So locking bytecode, again, just think of it as the address of the contract. In this case, must be equal to input 0. So we're basically just carrying forward from the input contract to the output contract. Output 0's token category must also be equal to input 0's token category. So again, token categories carries forward from input 0 to output 0. Same thing for the value. The number of Satoshis must be the same. Same thing for the token amount should be the same. And then we do output 1. So if we go up here, output 1 is the campaign NFT. So this is the actual campaign that the person is creating. So this is where there's a little more to it. So we're saying output 1's NFT commitment. We are going to create this commitment with all of these different values in it. So 1, 2, 3, 4, 5 things. So the first 6 bytes is the fund target. So the fund target is a number that we gave, and this was the number of BCH in Satoshis. And so this is where we check that the fund target has to be under this value, and then we stick it into this commitment in the first 6 bytes. We then put in a pub key hash. So this pub key hash, pub key hashes are 20 bytes. So again, 20 bytes pub key hash we gave. This is arbitrary at this point. It doesn't matter and can be anything. However, in this line, we are verifying that the pub key hash that we gave is the locking byte code's pub key hash for input 1. Input 1 is the user's input. So this pub key hash must be the user's address for its pub key hash. So that is getting slotted into the commitment as well. And then the next 4 bytes is the end block. So this is when the campaign ends. Once again, integer for end block, we did a check, must be below this number. And then 5 bytes of 0. So there's nothing in those bytes. It's just kind of a spacer. And then 5 bytes of the new campaign ID. So as we were talking about up here, if there were 5 campaigns on CashStarter currently, this would be this initialize, doing this whole process would be creating campaign 6. So it does a 5 plus 6 because we're currently at 5, we're adding 1. The end of this commitment, last 5 bytes, is where we put that ID. So that will put a 6 into the spot. And if you remember up here for campaign ID, this is in the same spot on the manager. So this is the minting manager. The last 5 bytes of its commitment were its campaign ID, the max value of the campaign ID. So if we're creating campaign 6, its commitment in its campaigns UTXO will be 6. That count up is the same for the master. It has the max value. So eventually, one day, if this CashStarter contract created enough campaigns, it would get all the way up to this number, FFFFFFFE, and then it would not create another campaign because this system would stop it from working. At that point, the CashStarter contract is bricked and it will not create another campaign. We'll have done 500 million campaigns at that point or something, but also you could just clone this contract and then keep going on a new contract. So yeah, I don't think it'll be an issue. So carrying forward for output 1, so this is the campaign UTXO we're creating. We're saying that it's locking bytecode for output 1. Basically, the address it needs to be going to, it has to go to a new locking bytecode CashScript hash 32. So this is actually something new with CashScript and BCH. So this is the CashScript hash 32 of the CashStarter contract. So this is not the manager that we're currently looking at. This is the script hash 32 of the CashStarter contract that we want it to go to. So we put in this value, which is the pre-computed CashScript hash 32 of the CashStarter contract, and we're just putting it in and saying that it has to go to this. So this is similar to how we do the other checks for locking bytecode, for example, up here. But this is using locking bytecode paid pub key hash. So this has to do with the user's addresses. But because we're sending it to a contract itself, it needs to use this CashScript hash 32. There was CashScript hash, but it was upgraded to 32. So if we actually check CashScript's website, it shows you the old CashScript hash 20, and then also the new CashScript hash 32. And just kind of explains how CashScript hash 20 was vulnerable to collisions based off being only 20 bytes in length. So script hash 32 is just 32 versus 20 bytes. This is mostly just an FYI, especially if you do have UTXO experience, maybe on BTC or another chain, but this is something to be aware of. So continuing on the contract, we have now specified that the address that we're sending this new campaign UTXO to is going to the CashStarter contract itself, and that's how we're locking this down here. The token category for the output 1, so again, this is the campaign NFT. It has to be equal to, where are we? It has to be equal to input 0. So this is the the actual minting NFT. So it's creating a duplicate of self because the input 0 is minting. It allows that. We specify that output 1, so this is the campaign, has to have 1,000 Satoshis just to exist. And then token amount is 0 because we don't have any tokens to put on it and don't really want them there. We then specify output 2. So this is the service fee. So the output 2 is a service fee to the provider. And then 3 is an optional change. So 2, all we're doing is specifying that the locking bytecode is equal to the service pub key hash. So this is just like using a user address. So service pub key hash going in here. So in FundMe.cash's case for the website, when you create a campaign, the website puts in its own pub key hash in this variable. And this is where it will actually pay that address when you create a campaign. The token category for that is going to be a 0. We don't want anything in it. It just needs to be BCH. And the Satoshis is going to be the service fee. And so this service fee is variable. It doesn't specify what it is. So this could be 0 technically. Or rather, I guess 1,000 Satoshis because it would need something to exist here for the output to exist. But the service fee up here is variable. The only check we're doing is that the service fee has to be less than or equal to 1 million Satoshis. So it could be half of that, a third of that. It doesn't really matter. That's the only check going on there. And then if the token or the output length is equal to 4, so there's exactly 4 outputs. Again, because of the numbering, 1, 2, 3, 4. So we're talking about the change. So if it does equal 4, then that fourth output, which again is output 3, because it starts at 0, its locking bytecode must go to input 1's locking bytecode. Remember, this is change. So we're telling it has to go to input 1. What's input 1? Input 1 is the user. So it must go back to the user. And then the token category is 0x. We don't want any tokens on it. This is just supposed to be BCH. So the one thing with this is you might look at the output length and say, well, we're checking that the outputs lengths is equal to 4. There's 4 outputs. Well, what happens if there's 5 outputs? Then this check would never happen, and you might be able to bypass it. That's correct, but that's also the reason if you go up here, we are limiting the outputs to 4 or less. And so that's why you can't bypass this check by doing 5 outputs because of this other implicit check here. So this is the CashStarter manager. So this is creating a new campaign. That's the whole process. The magic really is happening on this. We're creating an NFT, which is the campaign, with this commitment. It's got the fund target, how many Satoshis you want, the pub key hash of who owns it, the end block of when the campaign will end, spacer that I can't remember off the top of my head if I use it for anything later, but we'll find out. And then the campaign ID at the end. And then that whole thing gets sent to the CashStarter contract through this locking bytecode pay-to-script hash 32. So then if we look at the CashStarter.cash contract, so basically we've done the manager, we created a campaign. Now let's go to where it got sent. So if we look at this contract, just through the function. So we got a pledge function, and then we got an external function. That's it. That's all we got on this. So you can read all this stuff. Basically, all it comes down to is we have this pledge function, and it has an integer of a pledge amount. So again, this is in Satoshis. So somebody's going to call pledge, and they're going to say, I want to pledge this amount. So the layout of this function, again, for inputs, 0 is the campaign NFT. So just to make sure we're on the same page, we've done this. This is over now. It has now gone over and has created one of these campaign NFTs. So that's what we're currently looking at. We're looking at one of these. So we're looking at this campaign NFT in input 0. So we're pulling one of these one of these campaigns from the CashStarter contract. And we're also going to give it some BCH from the user. That is calling pledge. On the outputs, we're going to recreate the campaign and we're going to send it back to the CashStarter contract. We're going to create a new refund NFT and we're going to send that to the user that's doing the pledge. And then, of course, we're going to, I have the bad input there. That's supposed to be a 2. And then we're going to give optional change back to the user. So for this CashStarter contract, we're pulling a UTXO from it. That UTXO we're pulling out of it is a campaign because they're what exist on the CashStarter contract. So when we're pulling it out with the pledge function, because you have to call it with a function on the contract, we are specifying that the campaign coming out, its UTXO must be input 0. So the contract must have the campaign as input 0, otherwise it'll fail. So if we tried to move this campaign down to input 1 and put the user UTXO in an input 0, this will fail because the campaign is an input 1. So this is how the active input index comes up. I just wanted to go over that just because a couple people did mention that they weren't understanding this a little bit. So that's why the campaign has to be 0, because it's coming out of the contract. That's why that's there. Again, we input or we put limits on the inputs. So they say it has to be exactly 2 inputs, 1, 2. We put limits on the outputs. There has to be 3 or less, 1, 2, 3. Ignore my mistake 3 there. The pledge amount has to be greater than or equal to 10,000 Satoshis. And that's just the minimum amount you need, I believe. Once we go through this, we'll understand that. But you need a minimum amount on it to pledge to a campaign. The pledge amount also needs to be less than or equal to the 1.4 million BCH max amount that we specified earlier. We then check input 0. So again, the campaign NFT that we're pulling out, its token category must be the CashStarter minting category that we're talking about before, and it also must be a minting NFT. So the campaign that we created is a minting NFT. And the reason it's minting is because when people pledge, that campaign NFT has to be able to spawn new refund NFTs or pledge NFTs or receipt NFTs, whatever you want to call them, back to the user. So it has to be able to create a new child one. We then specify that input 1 must have a value of greater than or equal to 12,000 Satoshis. So the pledge is minimum 10,000 Satoshis, but the amount that the person is providing in their UTXO has to be at least 12,000. So that leaves an extra 2,000 for other stuff for us to handle, other things such as the miner fee that will come up. And then we just verify that input 1 from the user also has no tokens, just to prevent accidental burning of NFTs or tokens or anything. It should just be raw BCH. We then specify the outputs. So this is all output 1. So output 1 being the refund NFT that's going back to the user so that people can do refunds. So we're just saying that the output 1 that we're creating is the same as input 1. Input 1 is the user's BCH from their address. So we're just specifying it needs to go back to their address. Token amount of 0, shouldn't have any tokens. Value of 1,000. So we're specifying 1,000 Satoshis need to exist on this because that's what it needs to exist. And that's part of the extra 2,000 that we need from the 12,000 and verse 10,000. And then the token category of the refund or pledge NFT, whatever you want to call it, is equal to input 0's token category, split at 32, and then taking the left side. So input 0 is the campaign NFT. So if we look right here, so like this is input 0's token category that we've manually specified. So we're saying 32 bytes token category, excluding the minting capability. So we're just taking the token category, and since we're excluding anything on the end of it, that makes it an immutable NFT. So it won't be able to change itself, and it won't be able to spawn new NFTs off of it. And this is what we're giving to the user as the refund NFT, because we want them to have it, but we don't want them to do something to it. So then we're looking at the input 0's NFT commitment. So this is the campaign NFT again. We're looking inside its commitment. We're splitting at 31, taking the right side, and then splitting at 4. And this apparently gives us the pledge ID with 4 bytes and the campaign ID with 5 bytes. That might not make sense. That's okay. So this is a quick and dirty example of how I kind of like laid it out in my head when I was doing this. And this is what the splitting is doing, which makes a lot more sense when you actually have it mapped out like this. So essentially, for the campaign NFTs, so in this case, we're saying that we're going 31 bytes in, which is right here. And we are then getting these two fields. So just move that out of the way. We're going 31 bytes in to the commitment, which is to the D section on my little chart there, and then taking the right side, which is E and F, and then we're splitting at 4, which is the end of E. So we're splitting right there. So we have those fields 1 and 2. So doing that gives us the pledge ID and campaign ID. Campaign ID, we know what it is. It's what the ID of the campaign is that we created. Pledge ID is blank when it first starts because this is the pledge ID of the people that pledged. So it starts at 0. The first person that pledges gets ID 1. Next person gets pledge 2, etc., etc. So we then check campaign ID. It must not equal the minting one that or the minting master ID, the all Fs. So it cannot be the master ID. This one should never actually be triggered because if we look at this, the master ID is this guy. It's that NFT sitting on the manager contract. And when it runs through the logic on the initialize, it specifies that it cannot create the master ID of all Fs. So it should never make one on the CashStarter contract. So it is kind of redundant to have it there, but it's just something I put in when I was doing it and probably shouldn't have had there, but hey, it's there. We then kind of did the same thing as the campaign ID. So we're creating a new pledge ID. So if this is the first pledge on the campaign, this field will be 0 that we pulled out up here, and it just adds 1 to it. If it was a 1, it would add a 1 and become a 2 for a new pledge ID, etc., etc. We require that the pledges cannot equal this max number for the 4 byte value, which is a lot of pledges. And yeah, they shouldn't get that high. We then look into the campaign NFTs. So again, input 0, commitment, split it at 26, take the right, split 4, and take the left. So to bring up our handy dandy little chart again, so right here, we are specifying 26 right and then 4. So we are going 26 up right there, take this side, and then split at 4. So we're doing it right here and we're taking the left side. So that's narrowing us down to the end block. So we now have the end block from the campaign. We then require that output 1's NFT commitment has 6 bytes for the pledge amount. So this is the amount of BCH that in Satoshis that the person wants to pledge. 21 bytes of zeros, just as a spacer. The end block of when the campaign ends at. 4 bytes of the new pledge ID, which we just went over, creating a new ID for them for their pledge. And then also the ID of the campaign itself. We then are recreating the output 0, which again, output 0 rather is campaign NFT, input 0 to output 0. So first we get the commitment for that campaign. So look at input 0, it's NFT commitment, split it at 31 and take the left side. And the reason we're doing that is because we're going to set the NFT commitment for the campaign NFT. We're updating the pledge ID that we've created. So how many pledges exist on it. So first we got the first 31 bytes of the commitment. So we're just going to throw that back in because we're not changing it. We just want to carry it forward. But we're adding in the new pledge ID that we just created up here. That we've created the ID, a new ID for the receipt NFT. So that has to get updated. So we're throwing in that. And then we're also throwing in the campaign ID of this campaign, which we gathered right here. So we're not changing the ID. We're putting it in this variable, extracting it from the input 0 originally, and then we're shoving it back in to the same output 0 at the end of it. And then more of the standard, we're just saying that input zero's address must be the same as output zero's address. We're just recreating the campaign NFT to the same contract. Token category must be the same on the input and output. The value of the output, so this is the campaign NFT, its value must be equal to what it started with on the input, but it must also add the pledge amount. So this is what the person is pledging to the campaign. So if this NFT, this campaign NFT, this campaign was 10 BCH and they're pledging 1 BCH, well, this is where it's saying that the 1 BCH must be added on to the original campaign. And then the token amount must be the same token amount, which should be 0 for the campaign. And then just our optional checks for the change. So if the output length is equal to 3, so there's 3 outputs, then output 2 must go to output 1's address. So this is just the typical. If there's 1, 2, 3, so 3 outputs, that's where I messed it up. So if there is change of BCH from the user, it must be going to input, nope, wrong one. Input 1's locking bytecode. So if there's change, it must go to input 1. It must go to the user's address. And its token category must be 0 because we just want raw BCH and we don't want any tokens leaking around. So that's a pledge. That is everything that happens when somebody pledges to a campaign. It just switches around. It creates a pledge ID. It gives it recreates the campaign with that new updated pledge ID inside of it, that one field, and then the user is also getting a receipt NFT, refund NFT, whatever you want to call it, and it's tied to the campaign ID of that campaign. The only other thing in the CashStarter contract is this external function, which has almost nothing in it, and it is very open-ended. So in this case, we're saying that the active input index must be 1 instead of 0. And so this is just how the transactions look. And you don't see anything here because I didn't include it, which it'll show on the other function NFTs we'll look at in a second. But basically, if you're pulling a campaign NFT out of the CashStarter contract, so just like here, we're pulling on when you're pledging, you're pulling a campaign out and it has to follow all this logic if you're pledging. But if you're going to pull a campaign out with external function, the only things that it has to follow is that the campaign must be in input 1 and input 0 needs a token category that is a CashStarter minting NFT. So far, the only CashStarter minting NFTs we know of are either CashStarter campaigns, which are on this contract, or they are, or it is the minting NFT on the CashStarter manager. And if we look at the CashStarter manager, so if you want to pull the minting NFT out of this contract, the only function we have is initialize. So there is a minting NFT sitting here that could satisfy this, but to pull it the minting NFT out of the manager contract with initialize, it has to be input 0, which in this case it actually would pass that because it's checking input 0 for the minting NFT. It also needs exactly 2 inputs and 4 less outputs, which could technically pass, but it breaks down once you get to input 1, requiring a pub key hash address and no token category. So the no token category specifically for input 1, if we look back at the CashStarter contract itself, input 1 is what we're pulling out of the CashStarter contract with this external function. And in that case, we're pulling out a campaign NFT, which does have a token category, so that will cause it to fail. So it's suffice to say, this external function cannot pull the minting NFT from the manager contract, and it has to have the minting NFT capability as well, which is where the other contracts come from. So if we look at these contracts, we have a function cancel, function claim, function refund, and function stop. So these are on 4 separate contracts, 4 separate addresses. So just as an example, let's look at the refund. So looking at the refund contracts, it has 3 inputs, 3 outputs, potentially in this case. So the biggest part is the master NFT. So that's just the term I use for the NFT that lives on this contract that we're pulling from, just so that this logic gets called. And the master NFT is just an NFT with the category of the CashStarter minting master NFT, and it is also a minting one itself. And the logic for these functions make it so that you can't create more NFTs of the category. And the reason this has to be the CashStarter category and also be minting is just to satisfy that external function requirement in the CashStarter contract. So the reason the outputs are variable in this is if you're the last person refunding on a campaign, there's not going to be anything left on the campaign. No Satoshis will be remain, in which case the campaign will actually self-destruct, essentially, cease to exist. So if there's a campaign going that's currently active and has a bunch of people that's put pledges on it, then if you refund, the campaign will keep going, in which case this left side, so there's this little OR right here, the master NFT for this CashStarter refund contract will recreate itself. In both cases, it does, because we don't want this function to stop working for other contracts. So if this campaign is still going with other pledges on it, it'll recreate the campaign NFT as output 1 as well. And yeah, it'll give you the refund because you're calling refund with your pledge NFT as output 2. However, say this campaign was stopped. So it expired its time limit for the end block. So no more pledges can be done. So now the campaign is sitting there waiting for everybody to refund off of it. And once the last refund is done, then this side would occur based off the logic, which we'll go through, in which case the function contract will get recreated, and you doing the last refund will get your BCH back for the refund, but now the campaign just ceases to exist. So it's an implicit burn. So walking through the logic, so function refund. So first we're saying that this master NFT coming out of this refund contract has to be input 0. There has to be exactly 3 inputs. So the function NFT or master NFT, the campaign itself, and then the pledge NFT, which the user is providing because they did a pledge. And then the outputs are 3 or under. So again, this is because there could be 3 outputs, but there could also technically be 2 in our case. So then we look at input 0. So this is the function or master NFT for this refund contract. So we're checking, is it a CashStarter category and is it minting? It needs to be. We also check that the last 5 bytes, which is usually where the category or the campaign ID is, it has to be all Fs. So this is the exact same as the CashStarter manager, the minting NFT it has. These function NFTs are also all F. We then look at input 1, its category, and split it at 32. So essentially that is 32 bytes of a token category. So we're looking at the campaign because that's input 1. So we're looking at its category right here. And this is a category that this technically input 0, but this is how long it is. So that's 32 bytes. And then we're splitting off the capability. So is it immutable, mutable, or minting? So that's why we're splitting at 32. That leaves us with a category and capability for input 1. We then check that category. And it must be equal to input 0, which is also being split. So we're basically checking input 1's token category and making sure that it equals a CashStarter category. We are then checking the capability and making sure that it does not equal 0x. So again, this is hex, and there's nothing after it, so it's just empty. So this would be checking to make sure it is not an immutable NFT. It's not set like a pledge NFT or a receipt NFT. So those are sent and created to users. They cannot change the commitment on them because they are immutable. So we are checking that input 0, or rather input 1, which is a campaign NFT, is a CashStarter NFT, and it is not immutable. In other words, it is not a receipt NFT. It is not a pledge NFT that somebody shoved into here. This is an implicit. It should be a campaign NFT. We then do the same thing for input 2. So this is the pledge NFT that the user is submitting. So we check input 2's category. We split it at 32. That gives us a category and the capability. So in this case, I'm just tacking a 2 on the end just to differentiate from these two because they're different variables. So these ones are for the pledge NFT the user is giving. We check the category 2 of this input 2 and compare it and say that it should be equal to input 0's token category. So once again, we're saying that the NFT that the user is giving for their input 2 should be a CashStarter one. And then we also check the capability of that input 2 and say that it should be, in other words, double equals, it should be an immutable. So it should be a pledge NFT. So this is what's locking down that inputs 1 and 2 should be CashStarter NFTs, but which one should be where. We then check input 1, check its commitment. So we're once again grabbing the last 5 bytes of the commitment for the input 1, which is the campaign NFT. And the last 5 bytes is the ID number of the campaign. So yes, as we show here, campaign ID. And then we're checking to make sure that the campaign ID does not equal all Fs, because that's something only the minting master should have on the campaign manager. I think I actually have a note here. Yeah, this shouldn't ever be triggered. Once again, it comes down to no campaign should ever be created with this value, because it shouldn't create that last campaign to get it into the FF at the end. So this is kind of redundant, but it exists in the contract and it does check it technically. We then go into input 2, its commitments, and do the same thing. We are grabbing the last 5 bytes of input 2. So just to show again, input 2 is the pledge NFT. So this is the receipt that the user has that they're giving back in order to pledge. So what we're doing is we're grabbing what is the campaign this pledge NFT came from? What's the ID of it? So we get the refund ID from that thing. We then compare the campaign ID, which was from input 1, which is the campaign NFT, and we check to make sure that they're equal. So we're basically saying if you're going to refund with a pledge NFT, it better be for the campaign that actually created it. We then go into the pledge NFT commitment again, and we split at 6 bytes and take the left side. So this is the first 6 bytes of the commitment. That's the pledge amount. That's how much the person actually pledged to the campaign, and this was saved onto the pledge NFT. So we just hold on to this variable for the moment. We don't use it yet because we then jump into recreating output 0. So input 0 is the master NFT, so that's this refund contracts NFT. We are going to recreate it regardless of which situation we're in. It's going to recreate itself. So that's what we're doing here. Basically just saying, locking bytecode of input 1 or input 0, sorry, is output 0. So recreate token category, recreate the value of Satoshis, the token amount, and the commitment. Nothing special, just copy it from the first input to the next output so it keeps living on. We then run into an if statement here. So we're saying, so this contract, this refund logic is checking, is the Satoshi value on input 1 less than or equal to the pledge amount? So the user's provided a pledge NFT, and it has the pledge amount that says it was created with. So say something like 1 BCH worth of pledge. So look at input 1's value. Input 1 is the campaign. So this is the campaign that is collecting all the funds. So if the campaign is less than or equal to 1 BCH, it then runs this code in the if statement. If the campaign is larger than 1 BCH, it comes down here and runs everything within the else branch. So this is where we get the two different situations of the outputs, because those two, the if and the else, are the situations of is there funds remaining on the campaign, so it keeps existing or not. So if we run it through, so if the campaign is equal to or under, it shouldn't be under based off the logic of the flow of everything. But if it is equal to, which can happen if it's the last pledge that needs to refund after the campaign's been stopped or canceled, then it'll trigger this. So it will require that we recreate, or rather we do create an output 1, and its locking bytecode must go to the locking bytecode of input 2. Input 2 is the pledge NFT. So this is coming from the user. So we're saying that we're going to create an output 1, and it's going to go back to the user. It's going to have no token category. It's just going to be raw BCH. And the value that is on this new output 1 is going to be equal to whatever input 1's value was. So input 1 being the campaign. So it's basically draining everything that's left on the campaign except 1,000. And that's because it's paying for the miner fee. And then we put in a restriction here saying that the output length must be 2. So if this refund is the last refund on the campaign, we specify that it can only have a 2 output limit on it. And that's what this side of this little OR branch I have up here is saying. So the reason for this is because output 0 is a minting NFT. So this master NFT guy here, so this is a minting capability. And this is what we're checking here, is that input 0 is this. So we don't want to leave an unlimited number of outputs as a possibility, because that means this minting NFT will be able to create copies of the CashStarter NFT that it is. So we need to lock it down. So that's what this is doing. It's eliminating to 2 so that the user can get their refund, and that's it. So if this refund is not the last amount of BCH on the campaign, and if there's other people that want to refund still, then we run through this else branch. So this is recreating input 1 to output 1. So this is recreating the campaign NFT. So this is just the going from the contract to the contract again. We are copying for the token category. It shouldn't change. The value is the only thing that changes on it, basically. So the campaign is going back to the same contract. The only thing that's changing is the value. So we're taking the input 1 value, so the original campaign's value, and we're minusing the pledge amount, because this is what the pledge NFT had, and it's what we're giving back to the user. So obviously it needs to be deducted from the campaign. And then token amount and NFT commitment stay the same on the campaign. And then we also create an output 2. And this output 2 is the refund back to the user. So we're saying the locking bytecode for output 2 is the locking bytecode of input 2. And once again, input 2 is the pledge NFT from the user. So this is just sending it back to the user's address. Cannot have any token category. It will be raw BCH only. And the value, the amount of Satoshis on output 2 will be whatever your pledge was minus 1,000, again, for the miner fee. So if you'll notice in this else branch, there's no limit on the number of outputs. So that's something that should pop into your head when you're thinking of minting NFTs is, well, we're not restricting it here. So can we just create copies of the minting NFT and start wreaking havoc on the rest of the contracts? The answer was up here, no, you cannot, because we have restricted the max number of outputs to 3 or less. So if you run into this else branch, if somebody's doing a refund, you have created outputs 1 and 2, and output 0 is somewhere right here. So there you have your 3 outputs. You cannot go higher than that. So it's kind of like an implicit, already enforced. In this if branch here, we're actually restricting the outputs more. So this 3 or less outputs is technically still checked and active, But once we hit this if branch, we're actually restricting it more depending on whether this if becomes true or not. And that's the whole refund contract. So this is basically just we're pulling an NFT from this refund contract. We're identifying the NFT as what we expect it to be, so that this code kind of becomes trusted because we've created this contract with the proper NFT on it. So the other contracts can identify it. And we're just using this NFT to run this logic on the entire transaction. And that's kind of the fundamental how all of the functions work. So we'll just look at the claim function now. So this, again, is another function NFT. It only has the claim function in it, and it works basically the same way. So I just call it a master NFT that we're pulling from this claim function. The campaign, again, is input 1. The user provides some BCH in input 2. And we'll go through why we need the user there. And then the master NFT, so this function contract recreates itself so it can be used in the future by other people. The funds that the campaign has claimed goes to the user. And then there's also a service fee to a service provider. So the claim function needs a couple of parameters in it. So we need the pub key hash of whoever the service provider is and the service provider's fee, which is an integer and in Satoshis. So just running through the logic real quick. So active input index is 0. So this is the master NFT that we're pulling from the contract. So it needs to be input 0. There has to be exactly 3 inputs. There has to be exactly 3 outputs. Input 2's token category needs to be nothing. So input 2 is just BCH from the user's wallet. And this is just to prevent accidental burning of users' NFTs or tokens. We then have a little formula here for the service fee. So we're saying that the service fee that the function is being called with has to be less than or equal to this little formula. And this formula is basically saying that it's a maximum of 5% of whatever input 1 is, which is the campaign. So even if you're running a malicious website, you can't create a button that tries to somebody can click to claim their campaign that they've run and have the service provider, the website, take all of the funds. The campaign or the contract actually forces the campaign to only give a maximum of 5% to the actual service provider. And just to reiterate, there's also a maximum. It can be anything below that as well. And then we're just again doing our checks on our function. So this is the claim function, the NFT being pulled from this contract. So we're saying, is it a CashStarter NFT? And it must be minting. And then we're also checking the campaign ID at the last 5 bytes of its commitments to be all Fs again. And this is just kind of identifying the function minting NFT across these contracts. We then are grabbing the category and the capability from input 1. So we're splitting at 32 bytes and getting these 2 things. And this is a input 1, so this is the campaign NFT that we're looking at. And we're checking, is the category equal to input 0's 32 bytes? So we're saying, is it a CashStarter NFT? Because we know input 0 has to be CashStarter token category. So is it a CashStarter token? And the capability cannot be 0x. It cannot be immutable. So that means it cannot be a pledge NFT. So this should be a campaign. And then once again, checking input 1, the campaign, and we're checking to make sure it's not the master minting NFT ID for the campaign. Again, not needed, but it's there. So then we are looking at the campaign NFT again, and we're going into the commitment, and we're splitting at 26, and we're just taking the first 26 bytes basically. So we call that campaign info for now. We then do another split on that campaign info, and we're splitting at 6 bytes. So what we're actually ending up with is the fund target, how much BCH was the campaign trying to raise, and also the payout address. So this is the pub key hash of that was put into the campaign. So this is the creator's address essentially. We are then hashing that pub key hash that we just pulled out of the campaign NFT and making sure that it equals the inputs locking bytecode for input 2. So this is from the user. So whoever is calling this claim function has to give a tiny bit of BCH from their wallet just to call the function. So we're essentially locking down that whoever's calling this is the person that actually created the campaign with this check. Or rather than person, then the address. Whoever's controlling that address, the same address is the one that is calling this. We then also check the fund target. So we pulled out how much BCH the campaign should be trying to get, and we're actually checking it here. So we're checking input 1, which is the campaign. How many Satoshis does it have? And is it greater than or equal to whatever the campaign was trying to reach? So obviously, this needs to pass. It has to have at least the amount of Satoshis that they were trying to get. This little block here is probably getting familiar to you now. We're basically just copying forward the function NFT that is, in this case, the claim contract that we're calling. We're just saying that it has to recreate itself back to the same address, token category same, value same, NFT commitment same. Looks like I missed a space there. And token amount the same. So this is just carrying forward the function NFT so that it can exist and people can call it later. And then our next output that we're creating, so again up here, is just funds of BCH to the user. So that's essentially all this is doing. We're saying that output 1's locking bytecode must be the payout address, pub key hash that gets hashed, which this will create locking bytecode for it. So it must go to the user of whoever, or the address of the user that created the campaign initially. It cannot have a token category 0x. It's just going to be BCH. And the Satoshi value of this output is going to be input 1's value, which is the campaign NFT, plus input 2's value. So input 2 is the BCH that the user gave to do this transaction. So whatever they're giving, they're also getting back. And we're minusing the service fee. So this is the service fee the function's being called with, which is this formula right here, which breaks down to at maximum up to 5% of the entire campaign. So that service fee up to 5% is being deducted from the campaign that's being given to the user, plus 1,000 Satoshis. And that, once again, is for the miner fee. So this output 1 is sending the campaign funds to the user. This is the reason they even wanted to use these contracts in the first place. They are getting funded. So output 2 is going to be the service fee. So this is saying that the service fee puppy hash it, get a locking bytecode, set that for output 2. Cannot have any tokens, BCH only, and the value is the service fee, whatever it ended up being called in the function. So that is the claim. So in theory, that's walking through creating a campaign and straight up to actually pledging it all the way up and then claiming it. So that's kind of like CashStarter contracts start to finish. The only things we need to go over still are the cancel and stop. So we will let's do stop first. So this works the same way as the other ones in the sense that we have a master NFT just living on this CashStarter stop contract. Exact same thing. We check its category. We check that it's minting. Nothing different there. It has to be input 0. We restrict the lengths and the outputs. I'll just go over the note here. So this one says we're removing the minting capability from a campaign NFT. So what is stop doing? Stop is doing, so if you go to FundMe, for example, which this is technically the only portal for it, this campaign, the Bitcoin Cash podcast, has an end block of whatever this is. So this is still running for 24 days technically until it reaches this end block. Once it hits that point, technically nothing happens. The campaign will still be there and accept funds even after it hits this deadline. But the stop function becomes callable, and anybody can call the stop function. So we'll go through the logic. But what happens is that over here in the corner, I can't really select it, where the mouse is, there's a little red stop button that shows up once this timer runs out, and anybody can click it. So this is kind of like the workaround to cause campaigns to have a deadline that anybody can call. So looking at the contract at a high level, so it says this prevents pledges, cancels, and stops from happening. And this has to do with what this contract is doing to the campaign. But once that happens, you can still call a refund and a claim. Because if a campaign stops, it's just because it hit the deadline. It might be over the 100% that they're looking for funds, so you still want them to be able to claim. But it also might not be at the amount. So claim might not work because just implicitly it won't work because it doesn't have enough Satoshis. But you would still want people to refund after it stops. So you don't want this to go away. So let's walk through the logic and see how we accomplish that. So once again, we are restricting the transaction. So we're saying it has to have exactly 2 inputs. So that's just this stop master NFT and the campaign itself. Easy enough. The outputs, we're recreating the master NFT for this function. Okay. And then we recreate the campaign NFT, which is technically optional. So we then, we check those, put the limits on the inputs and outputs. We then jump into input one's commitment and we grab the campaign ID out of it. So we're just looking at the campaign NFT, grab its campaign ID, make sure it's not the master minting NFT ID. We then jump into input 0, which is the function NFT for this stop contract. And we say that the master ID must be the maximum value of the campaign ID. And again, this is just to verify that we're working with the right NFT. We then grab the end block. So we jump into the input 1, which is the campaign, and we do all these splits, just pulling out that end block field. So this is what block does the campaign end at. And we're checking a time lock of is the current transaction time greater than or equal to that end block. So essentially, has the campaign timed out, as have the miners hit the block where the campaign should be ending. We then go into self-preservation mode for the this stop function. So it's just verifying that it recreates itself with no changes between anything. It's just input 0 goes to output 0. We're just verifying that it goes from here to here and keeps living. We then check the value of input 1. So this is the campaign. So we're checking, is the value equal to 1,000 Satoshis? So when you initially create a campaign, it only has 1,000 Satoshis on it because no pledges have been made to it yet. So if the campaign is in that state where it has no pledges on it, or it got pledges to it and then people took those pledges off, it would then be in the 1,000 Satoshi state again. So if it is in that state, it has no pledges on it, all we do is we require that the output length is equal to 1. So up here, we check that the output length must be less than or equal to 2 by default. But if we hit this and check that the Satoshi value of the campaign is only 1,000, there's no pledges on it, we restrict it even more and say the output length must be 1. And we already have 1 output. So this master NFT went into self-preservation mode right here and recreated itself as an output. So if the campaign only has 1,000 Satoshis, we can't create any more outputs. So this is an implicit burn of the campaign NFT. The transaction to pass this, it will stop the campaign and it basically deletes it at this point. However, if the campaign does not have 1,000 Satoshis, so it'll have more than 1,000 Satoshis because somebody's pledged to it, we run the else branch instead. So in this case, we know that we have a campaign NFT that's here. So we send it back to the contract. So input 1 locking bytecode, which is the contract, the CashStarter contract, we send it back to the CashStarter contract. And the token amount stays the same and the NFT commitment stays the same. We're not interacting with that at all. The value goes down 1,000 Satoshis just to pay for this stop transaction. which is the initial 1,000 Satoshis that the campaign was initially created with. So this isn't taking any funds from pledges that have been made to the campaign. The only other thing that changes is the token category. So we set the token category. So output 1 is the campaign being recreated. So its category must be the token category of input 1. So what it originally was as an input, but we're splitting the first 32 bytes, which just looking up at this one, so it'll be this. Campaigns are 02, which is minting by default. So we're actually stripping that off and putting an 01 on it. So that turns the campaign NFT into a mutable NFT, where technically it can change its commitment. But in this case, we're actually using this capability as more of an identifier. So this is differentiating it from other campaigns, which are minting. And this is why up here in the description, it says that it prevents pledges, cancels, and stops. And the reason we're able to prevent these things is that if we look at the pledge contract, which is the CashStarter contract, if we look at the cancel and we look at the stop functions, like even so this one we're in right now, CashStarter stop, they check that capability. And if the capability isn't 2, it will not work. So that's what this line here is doing for the stop contract. So we're looking at input 1, which is the campaign NFT. We're checking its category, and it's an O2. It's a minting. So that means if a campaign NFT comes into this CashStarter stop function or this transaction, it will pass the first time. But because it gets set to mutable, it will never pass a second time. So that's kind of the trick we're using with the capability to allow this functionality to happen. And then last contract function is the cancel campaign. So same idea. It's preventing the pledging, fails, and cancels. Actually, this fail is supposed to say stop. I was originally calling it fail when I first made the contracts, but decided to switch it. It still allows refunds and claims. So what is cancel for? Cancel is for somebody that wants to, that has created a campaign and then decides they don't want to do the campaign anymore. So either they just don't want to, or maybe the price of BCH skyrocketed and it's now their campaign won't get funded because they're asking for too much, so they could cancel and recreate it or something. Whatever reason. So this basically stops the campaign early, and it's under the creator's control to do this. So this is basically the same thing as the stop one that we went over. The only difference is that it's the creator having to call it. So I'm not going to go through this one because at this point, if you've gone through this stuff, everything I've talked about, you probably get this. You can go through this yourself, most likely. The only differences are this payout address check right here. So this is basically verifying that whoever is calling cancel is the person that created the campaign. So how would you do that? You would look at the campaign NFT's commitments. You'd pull out their payout address. You hash their payout address, and you make sure that an input from the user matches. So what is input to? It is a BCH UTXO from the user. So their address is involved in it. You can then check that they are the owner of the campaign. So that is the V1 version of CashStarter, which FundMe.cash uses. A bit longer of a video than I was expecting, but hopefully you got some use out of this and understand it a little bit more. And these contracts enable us to create apps like this on Bitcoin Cash. And because all of the logic that we went over and all the contracts are just on the contracts themselves, this entire website isn't needed to interact with the contracts. The only thing this website is doing is showing you the text descriptions and the images, and that can be done in other ways. So this contract could be interacted with through different wallets and apps, and it's not locked down to one single place. So if you wanted to take a crack at interacting with the CashStarter contract, you could do it. and you could put in yourself as a service fee and actually make some money. And that's it.